So let me repeat a little bit on the slide. So polling is where the processor has to do all the heavy lifting by starting with some setup code. Then the processor will be busy checking the I/O control register or status register to find out the status of the peripherals. Every peripheral typically has a control or status register or combination of those two. And from checking the register, the processor can find out whether data is ready to be read into the microprocessor, or the resource is free for sending out any data that the processor is about to send. If that's ready, then the processor will service that. So, if it is input, it will be reading data, or if it's output, the processor will send data out. If the peripheral is not ready, then the processor can choose to check the other peripheral. And again, if the resource is ready, being data or for transmitting through the transfer registers, either way, the processor will be serving that I/O device if it finds out the device is ready. As you can see, the processor has to do all these checking. And we would like the processor to do things other than this. The things like we do data manipulation, we do computing, we do some logical reasoning, we check the values. So all the other things are the main things the processor has to do anyway, in addition to these polling operations. Polling makes sense if these control registers, these status are busy very often. Then these checking will not be waste, so it will not take much time as a part of the loop. But if the peripherals are rarely ready because they are slow, because their resources very tight, then you have to have the processor check all these peripherals and again. So those CPU cycles are wasted. I have to point out that if you really want to, first, if the peripherals are ready most of the time, and also you want very fast response, you might choose to use the processor to do polling. But for many situations, if these events are rare, the readiness of the peripherals are relatively rare or low probability, then you're wasting a lot of CPU cycles on doing this polling. I think I pointed out the advantages and disadvantages. So you should not regard polling as very bad always in any situations. Polling might be useful in some situations. So really you have to think hard what will be the best scenario that you can use polling. Let's look at this example of using polling. We have a Atmel AVR 8-bit microcontroller, and we want to use this microcontroller to send a byte over a serial port. We can have the following C code. What you see here, the first line is a while loop. And this UCSR0A, you can think about this is the control register of that serial port, like the UART controller. And this is one of the control registers in that UART controller. And we use the name of the register, that is to say, we want to read the value out of this register, and we're going to do a bitwise AND operation. And we're going to check in particular bit. I believe this is a bit number 5, if we're counting from 0. So that bit will tell me whether the transfer register is available. Remember earlier I said that the transfer register is the one that the UART will use to store the outgoing byte and then ship that value bit after bit and send the bit out of the serial TX wire. this transfer buffer or transfer register is not available until the previous byte is sent out completely. So that's the reason we want to check this to make sure that's indeed the case before we proceed to send the next one out. This UDR0 is the data register you will store the outgoing byte. And these two registers are defined in the header file for that particular microcontroller. And in fact, these two registers are memory mapped. So their memory addresses are some numbers we know from the data sheet. And that address is defined in the header file, and hidden from these individual exact memory addresses. So if we send out a sequence of bytes, we will have to do the same thing for all 8 bytes if your sequence is 8. So you have a for loop, and each of the loop iteration, you have to do the polling. So you'll be checking this control register to see if the transfer buffer is available. If it is, then we're gonna assign the outgoing value to this UDR transfer register. And because you are sending these bytes back to back, so when you get to the second iteration of the for loop, chances are the previous byte is still being transferred. So when you go into the second loop iteration, you might be stuck on this while loop for some time. So how long will this take to execute? If we assume the speed of the serial port is 57K, the baud rate is close to bit rate when we have this serial port transfer, 0s and 1s, because we only have 2 values here. Now, this rate will be transferred to about 140 microseconds for 1 byte. Assuming the processor operates at 18 megahertz, then we are actually spending about 25,000 cycles for each loop iteration. See if there's any questions. Is that semicolon placed in error, the one in the while statement? Okay, very good question. So this is the question about the semicolon at the end of the while loop. So this while loop, in fact, it does nothing but just checking the status register. It's not gonna execute this until the loop is done. So you only execute this UDR0 equal X subscript I to assign the outgoing byte to this data transfer register. You don't do that until this loop is done. So this is a kind of an infinite loop. The only breakout condition is the transfer register is available. So this semicolon is correct. That was a good question. For the receiving, it's very similar. You will be checking another register. This is the receiving status register. And you might be the same. I think it's a combination of the, so you're checking a different bit. This is to say if there's new byte being assembled as a new data ready to be read into the microcontroller. And if that's the case, this loop will break out and will return the value from this receive register. So the programmer must ensure there will be one data available before you can proceed. If there's no data available, then your program is going to stuck here because this while loop. The reading will take similar number of cycles as we calculate earlier. So from these two program segments, receiving and transmitting, we can see that polling has to be implemented as part of your program. We have to explicitly check the values of certain registers, certain bits. And based on the value, we'll determine whether we keep doing the polling or we can proceed on the actual operation for sending or receiving. In some cases, if there's no new data coming in, your program can stuck here. So whatever other functions you may have, you will not be able to execute those functions because your while loop is going to be stuck here.